Saxon's Trig, lesson 103, is calculations with logarithms and power of the hydrogen. So they do a review of a lot of things that you already know, such as 10 to the fourth times 10 squared. When you're multiplying the bases, you're adding the exponents. 4 plus 2 is 6. When you're working with logs and you've got 10,000 and it's multiplying with 100, you can really separate that to log of 10,000 plus log of 100, because when they're multiplying, that's really an addition. On page 583, they review if you have 10 to the sixth and you also have that to the 1/3, one base, two exponents, you multiply. 6 over 3 reduces to 10 squared, or 100. And the rearranging of log base x, oh, that wasn't a base, sorry, that's log x to the nth power. And what does that mean? If it's an exponent, it's really multiplying, so that is n multiplying in front of log x. And they then combine this with your log statement. And so, I'll write it out first. Log 10 to the sixth to the 1/3. You would take the 1/3 and multiply it in front of the log 10 to the sixth. And then your log base 10 and your 10 are canceling each other off, leaving you with 1/3 times the 6, and that goes back to being the 2 that we proved it was before. So they're kind of doing their exponents with their logs and just reminding you how all of those things work. Now here is the example, first example 1, of what they're wanting you to do. Write the following expression as a single logarithm. So they're giving me multiple parts and they want me to write it as 1. So they give 3 natural log of x squared minus 1 minus 2 natural log of y minus 4 natural log of x plus 1 plus 2/3 natural log of y squared plus y, and then end the parenthesis. All right, so if we want to write this with one term, we're talking one natural log term with the rest of this stuff put in the way it's supposed to be. So this 3 is multiplying. It really is then the exponent to x squared minus 1. And then I see a minus sign, which means that I have a denominator part to this, because the minus is really divide. The 2 is multiplying, so I know it's the exponent over here to y squared. The minus tells me that this other part is still in the denominator, so this is multiplying with x plus 1. It's multiplying with the 4, which makes it the exponent. Now I see a plus sign, which means it's a multiply up here in the top. And it was y squared plus y, and this was multiplying, so it becomes the exponent here of the 2/3. And that, I'm checking to see if they simplify it any further. I would not, I would leave it this way. Although they did not. They did a change in here with the x minus 1 and the y's. They pulled them out because they wanted to simplify them. If you get it at least this far, that's going to be okay. All right, so the simplification that they did, even though you don't have to do it, I'm going to show you what they did. So this x squared minus 1 can be split into 2 parentheses where the x goes to x and x. There's no middle term, so one sign is positive, one sign is negative, and one is 1 and 1. But each of those was cubed, so that has to remain with both of those factorings. Then they said, I'm going to pull a y out of both of these. which means that it's y with, and how much left over, y, plus, I pulled the y out, so I have to have a placeholder of 1, and the 2/3 has to go with both. And then at the moment, there's been no change to the denominator with the y squared and the x plus 1 to the 4th. Now, this x plus 1 and x plus 1 share the same information. There are 3 of them here. So if I move them down, I minus 3 from the 4 that I already had, dropping it to an exponent of 1. So 4 minus 3 is 1. Then they wanted to put this y term with this y term. So this stayed in their numerator and this stayed in their numerator. All right, so they moved it down. So they minused 2/3, y2 minus the 2/3. So to do that, they need a common denominator of 3, which makes this 6. So then that becomes y to the 4/3 when you combine it together. And so their final answer was the x minus 1 cubed and the y plus 1 to the 2/3 over top of y went to 4/3, and then this had dropped to x plus 1 to the 1st power, so we really didn't need anything else. Oh, wait, my natural log needed to be in front of all of that. Just double checking. I've given you what they had. Now, their y was at the back. That's okay, but that is the full information that they gave you. Now, example 2. Expand the following into the sum of logarithmic expressions, each of whose argument is linear. Again, that ending wording is clarification wording. Without it, you could potentially have other things. Square root x plus 1, whoops, parenthesis, and then z cubed, and that's all inside the square root. All right, so we are supposed to move this into its individual pieces. So we know that all the parts are going to have a log. We see first that there is an x and a y cubed that are multiplying together. So let's separate those into their plus formats. And the 3, which was the exponent, should be multiplying in front of the log y. Now I'm just debating which order to do it in. That's the top. Okay, so then this is the bottom part. So we're going to definitely minus, yeah, I put the log there, minus. Before I do that, let's change this x plus 1. Its exponent is a 1, but it's in a cube or in a square root. So we're going to change that to its fractional format. Oh, I did it again. I wrote cubed, I meant half. So x plus 1 has an exponent of 1 and a denominator of 2. And then the z, same thing, has an exponent of 3, a denominator of 2. Now it's no longer in the square root looking format, it's in fractional, which I need. So this one, the exponent becomes the multiply in front with log of x plus 1. And because this was also in the bottom, it's minusing 3/2 with the log of the z. Now that should be log x plus the 3 log y minus the half log of the x plus 1 minus the, yes, that is as far as they want it to go. That's all separated. The biggest thing there is remembering how you change a root into the denominator so you have fractional formats. Then you can solve. Part B is power of the hydrogen. So the 2 things that you need in your notes is that if you have 10 to the exponent of the pH, it will be a negative, and that will give you the hydrogen answer. And in reverse, if you need to solve for the pH, you will do the negative log of the hydrogen. So once those are in your notes, you're going to use them to solve example 3 and 4. Find the pH, so you want to use this formula, negative log of a liquid if the hydrogen is, so we're filling in 4.03 times 10 to the negative 6. Now that's in scientific notation, which you have not used in a while. but we still want to treat it just like we would. So our base is a 10, or you can just do it on the calculator, and that's probably a whole lot easier. But if you were rearranging it, you're basically saying 10 to what power would equal this. You know, it's going to be far faster. Just do this part, convert that over to its decimal format, log it, and then take its negative. And that will give you that the pH is 5.4. So your big thing there is play with that on the calculator till you figure that out. Example 4, find the concentration of the hydrogen. So now we're solving for the hydrogen, so we're going to use this one. 10 to the negative pH, and it says the pH of the liquid is 7.05, so negative 7.05. Again, that's calculator work. Your X to the Y or Y to the X button, or it might be, because that's based on 10, it might be attached to your log button. Wherever it is, that's what you're basically putting in, and then you have to determine if your calculator wants base then exponent or exponent then base, however it does. Your hydrogen answer should come out, and they're putting this in scientific notation. The likelihood is your calculator will spit it out in scientific notation, but if it would not, if it is fairly long, like a graphing calculator where it'll just list multiple things, you may want to put it in scientific notation yourself, because we typically want it in scientific when we're dealing with these very large or small numbers rather than in a huge decimal number.